In question 6, they give us an equation and say, part A, find the coordinates of the minimum point. What we should notice is in front of the x squared is a positive number. It's 1. And this is a quadratic. We know a fair bit about quadratics. Because it's positive in front of x squared, we know that it's going to be a smiley, so it will have a minimum, which means the minimum point is the turning point of the curve. And we can find that using x is negative b on 2a, which is 8 on 2, which of course is 4. And then to find the y value, we put the x value back into the equation. Y is 4 squared minus 8 times 4 plus 5, negative 11, and we have our point for negative 11. There are other ways you can do this. You could say, well, that minimum point is also a stationary point. So we could find out where the gradient is 0 and say dy dx, differentiate it, you'll get 2x minus 8. Where does this equal 0? Well, it turns out to be exactly the same, of course, where x equals 4, and from there we can put it back into y and find the point. Part B, the curve is stretched by a factor of 2 parallel to the y-axis and then translated by 4, 1. Find the coordinates of the minimum point of the transformed curve. Well, we have the coordinates of the minimum point, 4 minus 11. When it stretches, that means everything is, by a factor of 2, is multiplied by 2 away from the x-axis parallel to the y-axis. And so for that minimum point, that simply means it's going to go from 4 minus 11 to 4 minus 22 because the negative 11 gets multiplied by 2. So after the stretch, that's where it is. And then following the stretch, it's translated by 4, 1, which simply means every point moves 4 in the x direction and 1 in the positive y direction. And so our point will end up at 8, negative 21, and that's the minimum point of the transformed curve. Okay, in the last part, they ask us to find the equation of the transformed curve. So remember, it's stretched by 2 away from the x-axis, and then it's translated 4 in the x direction, and plus 1 in the y direction. Okay, so the stretch is done first. So when we are trying to find the transformed equation, we should do that first. And that's simply, we multiply the function by 2. And then we are going to do a translation. Right, there's 2 parts to the translation, in the x and in the y. The y part is simply, well, the whole function moves up by 1 because it translated in the positive y direction by 1. And so we end up with y is 2 times the function plus 1. All right, so the trickier part is then the translation in the x, which is there's something happening in the x. Now remember, when we're working with the x, it does the opposite of what it looks like. And so we're not doing x plus 4, we're going to do x minus 4. And this is our translation. All right, so we have the function x squared minus 8x plus 5, and we have to apply this. What we'll notice is we're going to replace x with x minus 4, and we're multiplying the function by 2, and that's the whole function. And then after we do that, we add 1. Right, so to do that, we're going to have a 2, we're going to open brackets because we have to put the whole function in there. Where we see the x, which we put x minus 4 squared. And then we have 8 times x minus 4 plus 5. Close our brackets where we're multiplying by 2, and then add 1. All right, so all we have to do is algebra to see what this turns into. So expand your x minus 4 squared and expand the 8 times x and 4. And collect like terms, we have 2 times, in brackets, x squared minus 16x plus 53 plus 1. And so you get 2x squared minus 32 plus 106 plus 1, 2x squared minus 32x plus 107. And we're finished.